This is to make sure you guys are understanding what is containers. Why do we need containers? What exactly meant by servers? What is a process and things like that. Okay. Can I get an understanding from you? What is compute? Simply.
It's a service that does some computation,
Uh,
processing.
yeah, does some processing. What it contains? CPU, memory, disk, and uh, that's more than enough. And okay, well, firewall rules could separate CPU, memory, disk. அது இல்லாம வேற என்ன define பண்ணலாம்? How can you define a compute? Simply a computer which is running some processes. Correct? Do you have any doubts on this particular basic understanding?
No.
No, sir.
No,
Sir,
right?
can you please repeat it on again?
So what is compute means it does some processing. It actually runs some processes. Or say for example, you have a Windows machine, right? Windows laptop. What does it do? You can actually browse some web pages. You can actually run some application like Word, Excel, or maybe some other installation of exe, some exe files and things like that. So how does it work? It is based on the CPU, memory, and disk available within the system. Similar to what your mobile phone has, right? It contains a motherboard, CPU, memory, and disk. Similarly, your compute will also have a CPU, memory, disk, and motherboard. What is an EC2 instance? It's an example of compute in AWS cloud. Correct? Any doubts on this? What is an EC2 instance?
No doubts.
Okay, why do we require compute? To run some services or host some application. When I say host some application, any clue you have? What do you mean by host some application?
Deploy some services.
Yeah, deploy some services so that we can access the application using the domain name or maybe the IP address. When a compute can be called as a server?
When it is accessed by multiple machines.
So for accessing also, what do you need?
IP.
Yeah, yeah, service should be, at least one service should be running.
Okay.
Must be running. And what else is required? The port should be accessible from outside world. Otherwise, if the port is not open, you can't claim that it is a server, right? Because I mean, you don't have anybody, nobody has access to it. So, is there any questions with respect to when a compute can be called as a server, or when a computer can be called as a server? Okay, I assume there is no questions. What is a service in a computer? It is just a process or a running service. It can be SSHD, HTTPD, Um, there are other services like LDAP. LDAP. So at least if one service is running, that service, a running service can be called as a service in a computer, a running process. Okay, what is an application?
Up- it's a application is the one that accesses the service or that uses the service.
So application basically it's built by developers and ready to be deployed.
Okay.
Correct? See, in general terms, I'm saying application means it is something which is built. That
Yeah.
means a build which is available to be deployed. A build which is available to be deployed on the server. That can also be service. How do you run an application?
They're accessing their IP address. I mean, if it is a web application, we are going to access it from the browser.
Basically, when I say run an application, it is nothing but making it available,
Okay.
making it available over the internet, or
Okay. Accessible through the
just
internet.
just running them. That's all. Running them means starting the service. How do you start a service? The command is systemctl. Systemctl start httpd. Any service you need to use systemctl command to. How many services we can run within the system depends on the CPU memory of the system. Correct? Any doubts on this?
Sir, are you sharing the screen, sir?
Or did I
Even
share my screen?
you
Okay.
cannot even
You should have told me. I thought I'm sharing the screen.
even I thought of asking that. Okay.
Okay, I thought I have started sharing. Okay. Just read through whatever I have typed. I'll just give you 2 to 3 minutes time so that if you have any doubts, we'll again go back. I'll anyways share this document to you. You can have a look at it. We'll also go for one round of corrections, and then later we'll circulate to the other people. So what do you mean by process in the system? A running service. It could be just any service, right? It could be SSHD or HTTPD, whatever you know as of now.
Okay.
This one we'll see some examples from internet. What is the difference between services and servers?
Service is a process that runs on the server.
Correct, exactly. That's correctly put. So if you have this understanding, right, you are almost kind of ready for any DevOps work because see that's where people really struggle. What is service? What is a server? When somebody says server, I mean people get confused. What is server? So how do you access a server or service? Either
Mm,
or
Public IP.
browser, right?
Is
Use
okay.
public IP or private IP. What is required to allow a service to be accessed from the internet? What does it mean?
What should be accessible and okay.
Firewall rule.
Okay.
Correct. You're correctly said. I mean, a port should be
Accessible.
open to access. And incoming IP address should be whitelisted in SG. What is SG?
Security group.
Security group. How do you disallow a service to be accessed from the internet? You simply don't define a security group
Okay.
or explicitly deny for a set of IP addresses. Okay. Anything, any other points you have to add here? The reason why we are trying to cover up the services server, how to run an application. Any idea why we are covering it again? Because Docker container or simply container, that is nothing but a process or a service that will be running to serve customer request. Okay, we are moving from native application to Docker container based application. Okay, got it?
Yes, sir.
Yes.
Okay, so this I have answers from ChatGPT. So this I'll share it to you. You guys, you can go through it. Just compare whatever answers we wrote it from here and then whatever answer we got it from the ChatGPT. Basically, all of these questions I only framed uh, thinking that it will help you to understand. Some questions may look repetitive. Some questions you may feel why it is required. So, how do you run an application? Any other questions with respect to Docker containers? I mean, before we go on to Docker containers, any other questions you have? Do you want me to explain about containers once again, a little bit?
Yes, sir.
Just a small brief would help, Shankar. Briefing should help.
Okay. So when we say containers, basically, which is running on top of the virtual machine. Say this is a traditional deployment where you run all the application on the physical machine. Correct? We are not even utilizing the existing hardware, existing resources, and we are not creating any virtual machines. That is a traditional way of deployment, where you end up wasting a lot of system resources. Then they came up with a concept for virtual machine, where you can maintain the consistency. You can create the operating system. On top of it, you can create the binaries and libraries. Binaries and libraries will be automatically available in the system. You just install the app on top of the virtual machine. And it is something similar to what you do in EC2, isn't it? What did you do in EC2? You installed Apache server, you installed Python web application, and you are trying to access it from outside world. So any questions with respect to running the application, accessing the applications from outside world, especially Apache and Python? Soumya.
Sir, it will show our application in the web server. It's using a web server. We will be uh, looking the output in the browser.
Correct. Basically, it is very similar to accessing any web application or any server in the internet. We are just hosting a very small application. Please don't mute. So there's a lot of noise. Okay. So running an application on EC2 is again similar to traditional deployment. Only thing is we are just making use of the VM concept where we are trying to utilize the existing resources and trying to still go with the heavyweight operating system. Heavyweight means the in order to create a virtual machine, you need to have a complete operating system running. The complete operating system requires at least 500 to 600 MB or about 1 GB of hard disk. So this is definitely a heavyweight. So okay, before that, I'll just show it to you. This the file that I shared with you. Okay. Can you all see what are the libraries required to install a particular service, a simple Apache service? Can someone read these packages?
Apache Portable Runtime Library.
Yeah. APR use ECR.
Yeah. APR additional utilities for Apache Portable Runtime Library.
Yeah.
Perl compatible regular expression
Only-
library.
Read only the first one.
Okay.
PCR, OpenSSL,
Okay.
ModSSL, zlib. So these many packages are required in order to run your application. I mean Apache server. What are the additional modules required to run the Apache server? These are all the things. All mod underscore some modules. What are the other different development tools required? All of these things are required. AutoConf, AutoMake, make GCC like that. GCC one of the C compiler. What do you need to do? How you install it? That you are already aware. Yum command can be used or apt-get command can be used. And in order to start the service, systemctl start HTTPD. Correct? Any doubts on that?
No.
So you basically need to start particular service. Is it possible to run multiple service of the same? See, running multiple versions of the same is not possible. Here they say involves careful configuration, right? Here they say 2.4.57 because there are only few uh, only one library you can maintain or one particular binary you can maintain within the system. If you want to maintain multiple versions of the same binary, I mean multiple versions of the same software, it is not possible. It is very tricky. So that's why it says it's require very careful configuration. Okay, you got it. Here they are trying to install two different versions, 2.4.57 and 2.4.54. they will maintain two different places for libraries and binaries. Again, that's going to create a lot of issue. How do we overcome that? By
Using Docker containers.
containers. So you can run containers and use host port and container port so that multiple versions of the same application can be running on the same machine. This is one of the use case. Apart from the actual use case, what other things you can do? You can do auto scaling. You can do monitoring easily. You can also move your container from one machine to another machine. So that is quite simple to run your application in an isolated manner, and it will be a lightweight operating system, lightweight application, and it is portable and auto scalable. So what exactly is required to run a container? That Docker engine is for Docker containers. For other containers, the other engines will be used. So you can see that all the binaries and libraries are built along with the container that you are building. That is why you see that bins and libs, and then on top of that you are running the application. Your container is started. So here, if you go back and see this one again, okay, it's here. So what is a native installation? It is as usual by running the HTTPD command using systemctl. Sorry, HTTP service, starting the HTTP service using systemctl command. Whereas when you want to run it using Docker, what you require is kind of, I'll show you that binaries and libraries which are built inside your Docker. Okay, the size of the image will be 25 to 30 MB if it is an Alpine based image. Alpine is also another Linux operating system. Debian is also another Linux operating system, using which we can build our Apache image. So you can see the list of binaries and libraries required. So here you can see that these are all the libraries which are required to run this container. So you can also see the APR, Apache Portable Runtime, OpenSSL, almost similar to what you see for a native kind of deployment. So you also see the modules that are packaged along with a Docker image. You also see the binaries, other configuration files required. These are the configuration files required in order to run your Apache. So this one, these are all the files required to build your Docker container and run your Docker container. So basically, whatever is there in the native application method, those binaries and libraries will be built inside a container image, and it will be shipped to this one, Docker Hub. What is Docker Hub? Any
To
idea?
store your Docker images.
It's a
Yeah,
kind of registry, right?
yeah, Docker registry. So where you store the Docker image and then you pull it whenever it is required. Why do we need to store and pull it? Any idea?
To make it used for everyone. So
Yeah, that is one thing for sure. The other reason is if you make some changes, if you keep it locally, it is not available for you next time. So you have to, so I mean, in fact, I mean it is used by many people. So you have to push your changes so that the latest build is available here and people can pull it from here. It can be a private registry, it can be a public registry also. If it is a private registry, you may have to log in and then download it on your local machine and test it and deploy it. If it is a public, it will be automatically downloaded and copied.
so it's like GitLab, sir.
See, protocol wise, you cannot compare, but some operations are very much similar. Pull is there, push is there, tag is there. Otherwise, it has very limited commands with
Okay,
respect
sir.
to Docker.
Yeah,
You
okay,
have
sir.
pull and push only for related to um, pulling it from the registry or pushing it to the registry. Otherwise, you have other commands like Docker run, Docker build. That runs only on the local machine. Okay, I'm going back to this one once again. See, Docker portable, isolated, efficiency, consistency, this and all. I mean, you have seen many times. So that one thing that you need to understand is containers are the application which is running by running the Docker. That means running container is running when you run the image, that becomes container. That means you have to do a Docker run. What is Docker image? Docker image is similar to an operating system, like similar to an AMI, which is built based on the Docker file that we create. And Docker Hub is where you store the Docker images and push and pull it. Volumes are um, important because I mean the volumes which normally Docker provides is not persistent. Persistent means it gets removed once a Docker container is killed. So you have to have a persistent volume that is mounted from the system. Mounted, any idea what is mounted? From one system to another system, something similar to you connect your USB drive that gets mounted right to your system. It is something similar to connecting your external device to your other device or to another device. That's what is called mounting. So that can be done in Docker so that the volume from the system can be mounted to your running Docker container. Say it's a Docker container, it is running. There is a volume which is mounted. This volume is persistent, that means it is not deleted. So if this Docker is getting killed and if it is running another Docker container, this Docker container will refer to this Docker volume. So that's how it looks like. That's how it works. So we'll see some examples over a period of 2-3 days. Then you can understand a bit better. Okay. So with respect to Docker file, what it contains, Docker file is a set of instructions which tells you which Docker image you are going to use by defining the from keyword. That will be the first keyword in your Docker file where you say from which Docker image you are pulling the image and then deploying it. Run is similar to running a command like yum install. Whatever command that you run, ls, cd, cp, all of those commands can be executed using the run keyword. Copy.
This base, Shankar, this base image, you mean whether it can be Linux machine or a Linux operating system or Ubuntu? Was that?
Yeah.
Did you see that base image? Okay.
But basically, we don't have to really look for Ubuntu or Amazon, because when we go for containers, we directly go for the particular application that you are going to deploy. Say, for example, if it is a Node.js application, you directly go for Node.js. It is already built on top of a particular operating system. It could be on Ubuntu, it could be on Alpine. So, depending on which application that you want to build, you use a particular image.
Okay.
For example, if you want to use Python, you go for Python. If you want to go for some other Django or something, you go for a Django,
Okay.
which is already built and made available. So work directory is similar to which directory you want to go and then do your stuff. It is something similar to changing the directory and doing operations from that particular directory. Copy is all about usual copy command, a CP command, but here we use copy from your host machine to Docker container. Copy command. So entry point is similar to setting a path for running a particular software. Say for example, Terraform, you remember you set the path in order to run the Terraform in Windows. Because by default, Terraform can be copied to any location, executable. But if you copy it to a particular location, if it is already in the path, you don't need to worry about running the Terraform command. Whereas if you copy it to some other folder like say export DevOps, you may need to add a path variable for that particular location so that Terraform can be picked up. Similar to that, entry point works in Docker container. CMD is the actual command which is getting executed when you run the container. So run, I said, right? I mean, these commands can be executed. This double ampersand means you run all of these commands in a single line. It is similar to the semicolon you put it in the command line to separate different commands. Okay, I'll move on to this one.
Should we write all these commands inside the Docker file? Whatever you showed now.
Basically, as a DevOps engineer, you will end up modifying something in the Docker file to make some changes or incorporate some new features. Otherwise, you need to know how to write a Docker file. That's all. If you don't have to be a master in writing the Docker file, creating the Docker file, because Docker file will be written by developers most of the times. They are the ones who creates a Docker file from scratch. DevOps engineer will be the one who modifies as per the requirement.
Okay.
Okay. So, okay. I'll probably stop sharing the screen. I'll ask you to go through the document from your side once. And I want you to start provisioning a EC2 machine using Terraform command.